can do like the class specified actions. And there are also two type of methods, like static and non-static. So if it's static, then you can only call it on the class, and it does not have access to instance variables. But if it's non-static, then you do it on the specific object. Um, and Java is a class oriented language, so everything needs to be inside a class. And the class is giving the blueprint for the object. So basically your class determines what instance variables you have and what methods you can have. So it determines what you can do to the variables. And we also have this special type of method called the main method that have like this syntax over here. You don't have to remember this. Whole syntax you just should be able to just recognize it, and that'll be fine. But when you run the code in Java, the only code part that will be run is inside the main method. So if you have a whole class and you try to run it and it doesn't have a main method, it doesn't actually run. So make sure to write your method calls here. And for our data types in Java, there are two main categories, the primitive type and the reference type. So for primitive types, their common ones are byte, short, int, long, float, double, boolean, and char. I think the pretty common ones are int, double, booleans. And for char, it's like kind of a new one. It doesn't have a equality in Python. It basically means like a singular letter, kind of a singular character. I think in Python you represent it as strings, but here there's a separate primitive type that represents it. So for primitive types are when we assign a name or when we assign a variable to it, we assign its actual values. So there will be like a certain bit long storage that just gives you like the number 2, for example, or the letter A. But the reference type is a little different. It can store everything else. So usually the common ones like lists, like array lists, like arrays, or anything like user created classes are all considered reference types. So for reference types, we also store like a certain number of bit to the variable name. However, you don't store the thing itself. Like you don't store the array list itself inside these bits, but you store its memory location. You store the memory address. And it's kind of like a pointer. So with that address, you know where to locate your actual object, actual reference type object. So here an example of declaring and initializing the two different type of data types. So for the primitive one, like we use int as an example, you declare it by specifying it's an int type, and then you can just assign the name with the value, like 0 here. But for reference type, we need to create an object. So we need to use a new keyword. And then since dog is a user created class, and we follow what the constructor of the class has. So in here, from this line of code, I know that the dog class constructor requires to take in the string, and here we user input the spot. So yeah, and now let's take a look at the golden rule of equals, which are kind of a way to assessing the values of the objects. So every time when you assign the equal sign between two variables, it actually does different things with the primitive types and the reference types. So they both copy like the bits, the number they stores, like a certain number of bits storage. However, recall that the primitive types you store the actual value. So when you assign equals between variables, it also just copies the value. But for reference type, we originally stored the pointers. So when you copy it, you also copy the pointer. So right now, when you copy the pointer, the two pointers gonna have the destination at the same point. So so that means that for reference types, if you mutate one of the objects that points to the same destination, then the other pointers, since they're pointing to the same thing, same location, the other ones get mutated as well. One exception will be strings. So strings are objects, are reference types in Java. However, they're immutable. So every time you're reassigning strings, it actually just reassigns the pointer instead of mutating the string object. So right now, we also have two ways to compare objects in Java. So there are the equal comparison and then the dot equals comparison. And they can actually do very different things. So be really careful when you are choosing between them. So equals compares to the bits that's stored. So then you can see that for primitive types, the bit stored is actually just the value itself. So equals will um, like do as what you expected for like primitive types like ints, for example. If both of them are pointing to an integer 5, then your equal returns true and false otherwise. The dot equals can be a little different, and it can be overwritten, so the users in their customized class can decide how they want to assess the equality. And this one is only used for objects, so only used for reference types. But dot equals doesn't only check whether the memory location is the same, but whether the bit stored itself, the pointer is the same. But it can check the instance variables, it can check the underlying variables in the objects to see if they're similar, if they're considered equals by the class. So let's look at this example. So we have X and Y, they're both arrays, and they have the same values at each index. However, they are not pointing at the same array. So the user created two array objects here so that X and Y are pointing at different locations. So in this case, X equals Y returns false. Does anyone know why or kind of want to share? Yeah.
Point to different memory locations.
Yeah, right. So remember equals, we just check the pointers, and here the pointers aren't the same. Yeah.
For strings, is if you make two strings like hello,
Mhm.
then wouldn't they be equal, and wouldn't that be true because they share the string pool?
Yeah, they if you assign two strings to like the same like words, there will still be different string objects because every time you assign a string, it's creating its string
I'm
object.
creating the string pool.
Sorry.
Like string X is equal to double quotes hello,
Mhm.
and string Y is double quotes hello. They will be, if you set them, they will be equal.
Using equals.
Yeah.
Yeah. I can double check on that one, but I'm pretty sure like if for strings, if you use dot equals, it still like works because strings are objects. So yeah, I can double check the equals in strings. Sorry.
I think dot equals is defined by the
Mhm.
so we don't think that the dot equals. Yeah. You can over the whole thing that we kind of like here, like override that equals. So you need to check the bits, which is good.
Yeah, but I'm pretty sure they use the string.
That might be true. You can check that.
Yeah, thank you for that. And then is it, yeah. Mhm.
It would like why you mean that like such objects were like dot equal. So can we call dot equal on like a variable like a or
Yeah. So dot equals only works on objects, so it only works on reference types. So but here like our A and B are primitive types, they're integers. So then you cannot use dot equals. Yes. Yeah. No. And yeah, but for here, if we use like x dot equals y, it will return true because the dot equals for arrays that it checks the each index and see if each index match up. So be careful when you want to use like assessing equality because sometimes you want to check whether they're you want to check the memory equations. You sometimes you want to check the inside values. Just be extra careful about the differences. And now we have like a past exam problem for you guys to try, and then it basically has four like similar implementations of like shuffling a deck of cards. And this particular shuffle, if you perform it 8 times, it's going to go back to its original order. So, and each of these while loop, you can see they intend to let the card go back to its original order. So that's the condition of stopping the loop. However, their variables are assigned differently. So try to um, see like how many times the loop will run for each of these four implementations. And yeah, feel free to try and think about it, and we'll come back together and discuss about it in a few moments.
What does borrow shuffle?
I'm not exactly sure how the algorithm was implemented, but in this question, you just need to know it takes 8 times to go back to the original order. Yeah, if you think it's possible that it can be infinitely many times, but yeah, so your answer can be in a number or you can do infinite times. Um, can anyone give me a sum up if you think we can go over it together as a group? Um, so yeah, let's start talking about the questions together. So let's start with part one. What do you guys think? How many times will the loop run? Anyone want to share? Wait, who's Who said, I heard zero? Yeah. Can you explain why?
Because deck two is just like pointing at decks, and that would mean that like it's already two, just not run that long.
Yeah, right. So, yeah, so we can see that we created new object, new card deck object for the variable deck, and then we assigned the new variable deck to the same object as deck. So, and then our condition for the looping is, well, deck two is not equal to deck, which means that these two are pointing at, well, these two are pointing at different objects. But since we assign them together, no matter what mutations we do to it, they are always going to point at the same object. So this condition for looping, this deck two not equals to deck, is never met. So the we never go inside the loop. So yeah, exactly what you said. And then, is there any questions? Okay, so what about the second one?
Uh, Second one, they will always be equal.
Yeah. So how many times the loop runs then?
Zero.
Yeah, yeah, you're right. So this is similar to part one, but part two, it's checking whether the each sequence of the cards are the same. But since every time we shuffle deck two, we also shuffle deck one in the same way, their sequence of the cards always the same as well. So we also never met the condition of the looping, so we don't go inside the loop. What about part three? Yeah. Yeah. Mhm.
They're both pointing at different objects.
Yeah. So here we can see we created new card deck object for the variable deck and deck two. And so they're pointing at different objects. And our looping condition is deck two not equals to deck, which means their two are pointing at different things. And we can see what we do inside a loop is always just calling this method on deck two. So we're never actually assigning deck back to deck two or deck two to deck. So we're not ever going to make them pointing at the same object. So we never end this loop, and this will end up in an infinite loop. So what about part four? Yeah.
I think
Mhm.
7 times.
Yeah.
Because like in the problem it says we have to perform 8 shuffles to get it back to its original order. And then we create 2 new objects and we shuffle the first one we shuffle deck 2 one time before we go into the loop. And then we have the correct implementation of equals in our case. So we just run it 7 times and then just go to equals deck.
Yeah, that's right. So here we're correctly checking the sequence, and then we want to shuffle 8 times, but we already shuffled once before the loop. So yeah, in the loop we shuffle 7 times, and yeah, pretty good. Like everyone did the problem. But I think this problem really helps to think about when you're writing your own code, like be aware of how like when you're creating objects, how like it can affect on the functionality of your code. Like I think the part one, two, three can be like um something you would write when you're writing the code, even though you have the same right logic, like you have the right logic of using like a well statement and then to check whether they come back to the original order. But like details like this sometimes can make the code run not as you intended. So especially for your test, which is all like yourself coding, just be extra careful about this. But yeah, I think you guys get the topic really well. Yeah, I think that's it for this part. Here are just the answers. And then yeah, thank you so much. And we will go on to testing and errors. Thank you.
Um, Hello, I'm Matthew. I want to quickly go over testing and errors because I know you guys have to do unit testing on your midterm, so I think it's important that we kind of go over the unit test library and kind of how unit testing works. So, a quick introduction to truth tests. So, truth is basically a package that's used to debug programs in Java. It's basically just a library, and you should be familiar with all the methods in that library when you're debugging your code. And so an example function here is like assert that your input value is equal to some expected value. So for instance, if I'm trying to see that my like multiply function works, I could assert that the answer to my multiply equation is equal to what I expected that multiply equation to equal to. And pretty much it basically just checks if the expected value and the input value are the same, and it spits out some error to you that it is not the same. And that's basically how true tests work. And another really important truth test function is not equal to as well. This is useful because you want to make sure something is not equal to something that you don't want it equal to. So, um, sorry, I'm trying to get the HTML to work.
This one got a little bit.
Oh, yeah. So quickly, sorry about that, but quickly, I'm going to go over an example with TrueTest just to kind of give you an example of how it works. We sadly do not have an example for this right now, but yeah, I'll kind of go over a little example myself. So, oh, shoot, do we, sorry. Yeah.
Sorry, my computer chose a very opportune time to log me out. So I swear it doesn't log me out like usually. Okay. Now it should work.
Yeah, so here's a little example of testing syntax. So for example, let's say here I want to test that my pairwise sum algorithm works correctly. So I haven't really implemented the pairwise sum algorithm on this slide, but let's just say I want to pairwise sum the elements in x and y, and I want to make sure that the sum to that is in x, and I don't change y. So an example way of doing this is I can take my deck, my integer deck of x and y, set it equal to two different values, right? Then I can call x dot pairwise sum on those two values, and I can assert that they're equal to. So this is a very common thing you'll see in truth testing in general, is you basically create an example input, which you can see in these two lines, and you can basically you basically run your function on your example input, and you want to check that the input is what you expect. And note that I'm actually checking two things here. Generally speaking, don't just check that the output is correct, check that you didn't actually edit the other stuff as well. For example, some questions will ask you to like destructively do something. So that would mean like the other array, let's say I want to make sure that my y is like null after I basically iterate through it. In that case, I would want to say that y.toList contains exactly and then nothing. So just make sure that when you're doing testing, that you call the function and then you make sure that you check that everything is exactly where you expect it to be after the call. Right. Any questions about this?
Yeah, sorry, I didn't get that. Why do we have to put like the in order? Like, what would it mean if it's like this Java kind of makes it randomly, or why do we put the in order in there?
I'm not 100% sure, but I'm pretty sure that the what do you call it? That the way that the dot contains exactly is like dot contains isn't like it is exactly. It means that it contains these exact elements. We're basically saying that it contains these exact elements in this specific order. I'm guessing that if you put 30, 15, 45 and didn't put in order, it would still work.
Okay.
Yes.
Wait, this
Okay. To see them run it, like it'll like be as if you like ran it away, like it'll affect it like outside of this with that statement, right?
So what you're saying is like things after that statement will like still act as if that method was ran.
Yeah.
Yes. In general, it's just a regular method like anything else. Don't think of it as something like above the code or different from the code. It is, yeah, just a normal part of the code. So in general, though, I think it is more readable if you run the function like before the statement and then check the values afterwards. I think that's a lot more readable. But yeah, in general, I think you guys have a lot of space to code, so I would not worry about trying to condense everything into a few lines. Yes.
I don't know if you know this, but do you think we'll be provided like a template like that on the midterm or not?
I'm not entirely sure, but I would highly doubt that they would give the exact syntax here. But I'm pretty sure you will have access to like looking at the library methods on your IDE. I think it might autocorrect for you, but I mean, I know you guys have a homework and discussion where you can like play around with the software they give you. I would personally go ahead and try and play around with that. Maybe it'll give it to you, maybe it won't. But in general, basically the only methods you really need to remember is like contains exactly, is exactly, dot in order, yeah, and then like how to define your method, your objects themselves. But yeah. Right, yeah.
When I want to like say like assert that something is equal to something, like when use the list of syntax.
No, you don't. So, for example, if I was want to do that, like assert that input is equal to output, I guess input is equal to expected. You can basically just put like a primitive in there if you want. So, is that what your question is?
I want to put in like this up there.
It depends. I mean, it depends on how your thing like kind of like checks that they're equals. So I guess this kind of goes back to what we were talking about like in the previous section with like dot equals and like how it actually knows that these two things are equals. If like your, let's say your ArrayDeck class has a dot equals method that can accurately like compare these two things, then you should be fine. But I think in general, the reason why you did dot to list in the project is because they want it in the format of like just integers like that. And I think that's just how what do you call it? Lists display their output. So it just so happens that lists happen to like look like that. Yeah.
Dot order that is that particular order.
Yes. So yeah, I think yeah, it's a little don't get me wrong, it's a little bit confusing, but it is basically that when you do dot to list, your list basically kind of like turns into the numbers that you see here. In general, I would just like yeah, I would just double check that like yeah. I think x dot to list is literally just these numbers in order. That's just like how Java proceeds it. All right. Anything else? Okay. Now we're gonna go on to interfaces.
Okay, so now I'm gonna go over interfaces. So basically, for interfaces, you want to define a contract with like the method signatures and implementing the different classes that they must fulfill. So the actual implementation of these methods doesn't actually matter, but they just have to happen. So I'll go more in depth on them with the example later. Allow for abstraction and decoupling of code by separating definition from implementation. And it also supports polymorphism. So basically, like different classes can implement the same interface. Enable multiple inheritance of type. So a class can implement several interfaces. So now we'll take a few minutes to go over this question one. It's from Spring 2025, question one. So yeah, just take a few seconds to look over the question. And then we're doing part A first, so just look over that. And then we'll kind of debrief on that. Okay, so you have a interface called chatbot, and then you have two methods. You have an answer query is non-default. So and then the other one is default. It's called my info. So does anybody have, so for the first one, if you don't have a answer query method implemented in the CS61B class, it won't compile. So for the like kind of inherited kind of parent class, if you inherit from an interface to run, you need to implement the non-default methods in the interface. So over here, the non-default kind of methods is answer query. So if 61B bot doesn't have answer query, then it won't compile. However, if it doesn't have the my info, it will still compile because my info is a default method. So the only rule kind of with implementing methods from the interface that the class is inheriting from is you need to implement the non-default methods. So in this case, answer query. So if we override my info, we must add an override tag. So this is also false because override is recommended. It's very helpful, but it's not necessary again. So that one is false. And then for the fourth one, if we do override answer query, our program may crash at runtime. So it won't crash because crash is referring to runtime, right? If you don't have the answer query implemented in the class CS61B bot, it will just not compile. It will not even start running. So for 61B bot to even like kind of pass the compile, it must have the answer query implementation. So that one is also false. For the fifth one, we can define a constructor for CS61B bot, even though the interface doesn't list any constructors, and that is also true. So we can just go on to the next slide. So yeah, so the second one is true, and we went over why because you just need to implement the non-default methods, and the fifth one is also true. So any questions on A? Yeah.
Why is the fourth one not true?
So the fourth one is not true because it will so you refer to crash for like you run to error during runtime, right? But then this won't even compile. This won't even start running. Yes. So that's a very good question. Okay. Oh yeah. Yeah. So for the fifth option, right? So any class can define a constructor, but the like interface doesn't prevent you from adding additional methods. So the only rule about implementing for like classes implementing methods from interfaces is it has to implement the non-default methods. And a note about that is that static methods, they're also like they're not inherited. So if you have a static method in the interface, that is not inherited. So only non-default. Does that make sense? Okay. Any other questions?
Is it good practice to override my info though, or do you not override default methods?
Yeah, so it's not necessary to be overridden.
Okay,
Yeah.
you're not doing anything wrong.
Yeah, I think so. Yeah. Okay. All great questions. So now I'll go on to B. Oh shoot, this shows you the answer for B. So hopefully you guys didn't see the answers for B. So please look over B. This B is the 61B bot it implements the chat bot, which was the interface on A. And as you can see, it overrides or it has implementation of answer query, as well as my info. So again, to your question here, like, would it be wrong if we did have a my info? So it's perfectly acceptable. It's just not necessary. And then you have your static main that creates an object and then kind of runs through an example. So what happens when the main method is executed? You guys can like discuss within your tables as well, like give it a few minutes. Okay. So I hear a lot of great discussion going on. Okay, I think we will just jump into kind of the answer or explanation for this. So the answer is it will print the CS61B bot version 5. So I'll just kind of walk through it. So you define your instance bot of type CS61B bot. And then you print out bot.myinfo. So bot is, if you look at the dynamic type, it is CS61B bot. So when it calls myinfo, it will first look in the 61B bot class for myinfo, and then it will run that, and then it calls or returns version info, and version info is set to 61B bot version 5. So therefore, the program prints CS61B bot version 5. Do you guys have any questions on that? Any questions on part B? Okay, so also a note about this is, so static elements or instances of a class can be accessed from instance and instance methods. So in this case, because the version info, it's a static variable. And if you guys remember, you can only access like static variables from kind of static methods or, with instances of the class. So in this case, it is permitted because like version info is static, but then you're accessing it so you're accessing the instance. Sorry. So instances, with instances, you can access instance methods and variables and also non-static methods and variables. So yeah, that's just kind of an extra note at the bottom that they want to remind you of kind of like the static type and the access limitations with the static type. So yeah, for the part B, CSX1B bot, it prints the CSX1B bot version 5. Okay, so that is all for interfaces. Yeah, any last questions? Uh,
Um,
yeah, so basically, if you have a non-static so if you have like a if you have a non-static method, it can access both, right? If you have a static, it can only access other static methods or variables. So yeah, that's a kind of limitations on static elements or instances. Yeah.
So can static methods access like instances that we created from a class or not?
Yes.
Okay.
Yes, that is permitted. Any other questions? Okay, awesome. So we'll go to the next portion, which is iterators and iterables.
All right, hi guys. An iterable is an object that can return an iterator, typically by implementing an iterator method. So iterables are an interface, and you kind of have to like implement an iterator method if you are implementing an iterable. An iterator provides a way to traverse elements in a collection. So go through like the iterable. And common methods include has next, next, and sometimes remove. Actually, give me a second to read this here. I think sometimes the difference between iterable and iterator can be confusing. So think of this metaphor, right? An iterable is like a playlist of songs. And within the playlist, there's like a function to go to the next song, right? Like the skip button, go to the next button. Like think of that button as the iterator. Each playlist comes with such a function that allows you to go through all the songs, right? And the iterator in this example would be the play next button. I don't know if that metaphor is helpful, but to me, it helps to remember the distinctions between these two. Um, Iterators also allow clients to iterate through a collection without exposing its underlying structures. This is how for each loops work under the hood. So when you have an iterable and you run a for each loop, we're actually really just calling the iterator and returning each of the elements within the iterable. So next, I'm gonna give you guys a few minutes to work on this question. Basically, you are implementing the class schedule, and Harvey wants to check on his patients repeatedly in a loop. Yeah, I give you guys a few minutes to think about this. Kind of important thing to notice is it kind of loops around, right? Like even though there's only 3 patients, if you call the next patient function 5 times, it should still return something. It's a pretty important detail. Does everyone need more time to work on the question, or do you guys want to go over the solution? Yeah, let's take 3 more minutes here. Okay, that has been basically 3 minutes. Um, does anyone have a good guess of what goes in the first 2 blanks? Yes.
You could do the patients equal, the first one you could do patients equal patient,
Yeah,
and then the second one you would do patients iter equals patients dot iterated.
yeah, exactly. Um, I think that is a great problem solving approach. Like if you see this, the first function is almost always just, taking the inputs and assigning that into the variables in the class. You're exactly right. This dot patience equals the patience we pass in, and this dot patience iter equals patience dot iterator. I think for the next function, the most intuitive approach, if you're like absolutely completely lost, like don't even think about the looping around stuff first, right? How do we get the next patient? You just call the dot next function of the iterator, patience iter. And as you can see, that matches our function, like signature. We need to return a string. This is how we would return a string, like return patience, iter dot next. Now, how do we solve the problem of when an iterator reaches the end, it errors out, right? But we want an endless cycle. So this is exactly what this code does here. So we checked if patience.iter does not have a next, right? We're at the very end. We actually assign patience iter equals patience.iterator. Again, we create a whole new iterator to like replace the patience iter once it has reached the end. Does that kind of make sense? Yes.
This,
Um, I think you don't necessarily need to, but it is just good to use this dot patience equals patience because that way, like you like won't get confused. Like what patience are you assigning to? Also, it lets like the language know that you're specifically referencing the class variable patience because as you can see, like the input variable name is also patience, right? Like that gets very confusing. If you do like, for example, um, patience like bracket 0, right? Like, are you talking about this or are you talking about the class variable? So I think it's good to use this dot when you're referencing the variable in the class. Um, if this is like kind of confusing, like this code here, I can also kind of walk through like an actual example. But if we're all good on this, we can go on to the next part of the question. Yeah.
So like when we have like the iterable, when we like assign it to iterable reference, like or iterator reference, do we like assume the methods like already like made, or do we like this? You know how we have to make our own, we have to implement it ourselves for like the project two. Is it typically always already made, or like unless like it's not in the interface or something like that's clear.
Yeah, actually, that's a really good question. So, if you get a problem that specifically asks you to implement like an iterator, right? For example, public class schedule implements iterator. That means that you have to write your own like next function or has next function, right? But if you're getting an iterable like patience, you can assume that this iterable already has a dot iterator function and you can assume that the iterator that this returns already has like the has next and the next function built in. So unless like the questions explicitly ask you to like override the has next or next method, just assume that it works like normal. Yeah. That's a pretty good question. Any other questions? Yes.
Just like go. I'm a bit confused, like why do we have to like replace it with another iterator, but it don't have to get any next item?
Yeah, that's actually a really good question. So, for example, looking at the example they've given us, right? Maru, Sebastian, and Pam. If we put all of these in an iterable, right, like a list, and we take the iterator, we call the iterator method of this iterable, and you call like dot next, right? First you get Maru, then you call Don next, then you get Sebastian, then you call Don next, and you get Pam. But when you try to call Don next again, you'll get an error that's like there is no next one because you're at the end of the list, right? The thing is, the problem wants us to be able to call like next patient more times than the actual length of the iterable. And what they've said that if you call like, like the fourth time, it should kind of go back to the beginning of the list. And in order to do that, you can basically create a new iterable, right? So once this iterable runs out at Pam, if you create a new iterable, or if you create a new iterator, then the new iterator will start fresh from like, the front of the list, right? Because for each um iterable, you can create as many iterators as you want. It's just that each iterator, will reach the end if the list is ended. Yeah. So we're checking like, oh, this iterator has run out. Let's create a new one. Let's start from the beginning again. Yeah. So for the next question, we unfortunately can't find the original problem statement, but this is close enough. You're given several lists of patients, each representing a priority level, 0 to highest priority. As you can see, we're taking in this list of priorities here, which is like a list that has other lists inside, and implement a class priority schedule that implements iterator string. The iterator should cycle through each priority level in order. From priority level I, return n minus I patients before moving to the next level. Wrap around the beginning when you reach the last level. Continue indefinitely. So this is kind of like your question from earlier. If we're implementing the iterator interface, then we have to define our own has next and next function, right? So I'll give you guys some time to work on this. It is a little bit more involved than the last question, but yeah.
What is priority properly?
Yeah, so priorities is a list of like, I want to say string lists, right? So it's like a list, and each index of priority represents how much priority to give to that list of patients. For example, the 0th, index of priority probably means like this group of patients is the most important. Index 2 or something is like,
So priority
yeah.
is basically like the answer to return the recording as next to return the string of the what? The patient's name.
So I think you need to return like some patients. Yeah. Yeah. Also, yeah, we don't have the original problem statement from the actual test, but you will need to use the schedule class that you've implemented previously. Yeah.
Oh,
Yeah. Yeah, let me double check. So this is a little bit confusing, but I think basically for each um of schedules, right? You see a list of schedules. For each of the schedules, you should be seeing up to like a certain number of patients. And then once you've seen that certain number of patients, you should go to like the next patient, if that makes sense. Yeah, I wish we had the original problem statement. This is kind of confusing to implement a problem without knowing like exactly what it is. All right, I think I'm just gonna go over the problem just because it's a little bit hard to like accurately work on the problem without knowing what it's asking. So first, as usual, we're gonna start by defining all of these class variables here, right? We're just gonna assign this dot n equal to n, and this dot schedules equals a new schedule with priorities dot length, right? We need a list of schedules as long as priorities because yeah, like each of the elements within priorities represents a set of people we need to see. So this part makes sense. And now we need to populate this new this dot schedules list that we've created. So we're gonna loop through, you know, the priorities dot length, and this dot schedules I equals new schedule priorities I. So as I mentioned before, priorities is like a list of lists, and within the lists, there's like names of patients and stuff. I think sometimes it helps to like visualize what the data looks like. So even just drawing out a few examples, right? Like, Sam, Marcus, that's a list, or like Olivia, Fred, whatever, like that's another list. That's what the data kind of looks like. And we're creating for each of these lists of people, we're creating a new schedule and putting it into the list of schedules here. So hopefully that makes sense to everyone. Now we're gonna implement the next function. This is a little bit confusing, but the next patient is schedules like index.next patient. So index is something we'll be keeping track of here. Yeah. So we're obviously starting from index 0 because that's like the highest priority in the priorities list. Because priorities goes from most priority to like least priority. So we're starting there. And hopefully this part makes sense to everyone. Every element within the schedules list is a schedule, and we just implemented the schedules next patient function here. So hopefully you guys understand that we're returning the next patient within the schedule I, or schedules index. And then num seen in index plus equals 1. So if we've seen like a certain number of patients that are greater or equal to like n minus index, honestly, I wouldn't worry too much about this. This is probably specific to the question, but because we don't have the question, we don't have to worry about it. This part is kind of important though, right? Like once we've seen enough patients from this schedule, we need to go on to the next schedule, right? We need to increment index. But because we want this to loop around forever, this is why we have the +1 modulus schedules dot length. This means that like even if our index is longer than schedules dot length, like longer than the actual length of schedules, we can still loop back at the beginning because of the modulus operator. So we're basically always incrementing index by 1 and then finding the remainder of that number divided by schedule's length. And then we reset num seen and index equal to 0. And then we go on to the next patient. Or we return the next patient that we found here. This is the string that we're returning here. Hopefully, even though like we don't have the problem and it's hard to implement it, you guys learn some good problem solving techniques, such as like starting from this function, implementing, the assignments and understanding like the types of data they pass in. Hopefully that was still a good exercise. Okay, Matthew, do you want to cover this or?
But do you guys want after iterative questions? Would that be? Now we can move on to other stuff. But would this be useful to go? Let's go through this.
Still a question?
Yeah, there's probably a question about like why do we need like not like for example like we wouldn't do like this priorities those priorities.
Let me see. Oh, okay. So the reason why you wouldn't do this dot priorities equals priorities is because up here, like as you can see, we don't really have like a variable called priorities, right? If we did have, a variable up here called priorities, where we can store what they've passed in, then you could totally do that, and you probably should do that. But for this question, they're kind of expecting us to like use the priorities like inputs and create schedules based off of that.
So it's already like then we like kind of keep the information like within it.
Yeah, exactly. It's almost like we keep a copy of the information, but in the form of a list of schedules rather than just like a normal array list of strings, right? So now we have like a list of schedule objects that still has the information within priorities. Yeah, yeah.
All right, so here's another just iterator question. So we're gonna find this thing called a less than or equal to iterator or an LEQ iterator. And pretty much we're gonna we want an iterator that basically iterates over this int list. Just for a reminder, an int list is a singly linked list with integers. And then we're basically gonna only iterate over the ones that are less than or equal to the start of the list. So I guess just to kind of show you like the example here, the start of the list is 25. So the values that you'd iterate over that are less than or equal to 25 are 25, 10, 5, and 25. So yeah. I'll give you guys like 5 to 10 minutes to work on this, probably more like 5. But yeah, just kind of think about how you would kind of like know what the start of the list is, how you can store it over the entire like runtime of your iterator, and also think about like the has next method and the next method that you guys seen in the previous problems. How are you guys doing with the problem so far? Do you guys need more time or?
The next one is. Yeah. It's, very-
Yes, maybe. Um, yeah, well, yeah, actually, let's just start going over it right now, kind of like section by section. So, does anyone have any ideas for the two private variables we defined at the start? Um, any ideas?
I was thinking like a list and so I just did like the index just did like that first.
Mhm.
English was like per.
Yeah, no, that's actually exactly what the answer has. So yeah, so you find first a in list for the current value that you're currently on when you're iterating, and then you also want to have the integer for the front number. So yeah. Yeah, I guess we can also go into the constructor right now. How have you guys looked at the constructor? Any ideas?
We do first equals O dot first and then
Mhm.
current equals L.
Yeah. So yeah, I think this is a generally pretty straightforward iterator. So yeah, you're right. The current you set to equal to the L, which is like the pointer to the first thing in your int list, and you set your front number that you're keeping track of as the first element in that list. Okay. Um, do you guys still want more time actually to go over has next and next, or do you want me to just explain? I think in the sake of time, I think I'll just explain. So for how's next, you pretty much want to check if the current value is not equal to null. And the reason why you want to do this is because you can imagine that your current value is pointing at some value in your int list, and you want to make sure that it's not pointing at some null value. And so the way you do that is you just basically check that your current pointer is not equal to null. So for next, pretty much getting the next thing. So whenever you get a next value, what you have to remember is that you need to get the value that you're on right now, and you want to return that. But at the same time, you also want to go on to the next value. So the way that we do that here is we take a number to return as the current dot first, so wherever we're pointing to, and what we do is that we iterate to the next one. But in this case, because we're actually trying to get only numbers that are less than or equal to, we basically just keep looping through the current dot rests until we basically find a new number that is less than the front number. Um, yeah, and then after that, you just basically iterate it one more time, and then you return, what do you call it? You return the number that we got before. Okay. So I went through that a little bit fast, but does anyone have any questions about this? Do you guys want me to spend a little more time on the slide, or are we fine to move on? Okay.
Hi, I'm Ganlu, and then I'll be going over arrays, linked list, index, and I'm gonna go over like the conceptual parts. So first, let's look at array. Array consists of number sequence of memory boxes, and then we can access item within an array through index. And then remember that arrays are zero index, meaning that if you do like array square bracket 0, it will give you the first item in the array. And then array consists of a fixed integer length. Meaning that, like, for example, when you instantiate an array, you need to pass in like the length and then it will stay fixed. And then you can copy over arrays using a loop or array copy. And here's an example of array copy. It basically means that you copy two elements from array B starting at index 0 into array X starting at index 3. I've personally have never used this when I was learning 61B, but it's something good to know. And then here's an example of an instantiation. There are two ways. First is that you can use like data type square bracket variable name equal new variable like data type, and then you pass in an integer representing the length of the array. The second type is that if you already know what elements you want to like pass it into array, you can directly use like the second type of like, yeah, like, and then there's a special use of array that like might not necessarily be useful for this midterm, but it might be useful for final where they kind of like limit the lines of code that you can have, is that the index of the array can have like concrete meaning or representation offered under different contexts. For example, if you create an array of Boolean, like the index could represent something that you're interested in. For example, you have like 5 boxes and you want to know if there's like a candy within the box. And in this case, you can use the array, and the index from 0 to 4 will represent the 5 boxes. And then if the corresponding item is true, it means there is like a candy within that box. So this could be something good to know for the exam. And then we can go to singly linked list. It's a linear data structure consisting of nodes being linked together. And then each node contains 2 pieces of information, which is essentially like the item in the next. And then here's doubly linked list. Each node contains 3 pieces of information, data field linked to the next node and linked to the previous node. And now let's look at like a comparison between singly linked list and doubly linked list. The top one is singly linked list. You can see that there's only like pointer to the next. And then the second one is a doubly linked list. You can have access to the previous node as well. And here's the implementation. And now you can also see like the difference is that doubly linked list, they have like an additional instance attribute of like a prev. And then here's the array list. Array list is also 0 index. An array list is a collection of order objects. And then order objects here means that it will like maintain the order of your insertion. For example, if you do like add A, add B, add C, it will remain the order. It doesn't mean that the objects will be sorted. And then you can also index into the array list to access elements. You can iterate through its elements using a for loop or indexing. And here are 2 examples. The left one is using an enhanced for loop to iterate through the array list. And then the second one is to use index to iterate through an array list. And then array list implements Java's list interface. And if you want to learn more about the methods, feel free to use this link, and it has like more detailed documentation. And here are some questions.
You can't adjust the size. And then to index into the array list, you use the dot get rather than square bracket.
Yeah, we will get to that after the slides, but good question. So here are some important methods for array list. I think, will they give you reference sheet for the exam? I think those will be on the reference sheet, so you don't need to like memorize all the methods. Here are the difference between array list and arrays. First, the array has fixed size. However, array lists, they have like dynamic size. For example, it's called like geometric resizing. When you keep like adding into array list and you hit a threshold, you will resize the array by X or like a certain factor times the size of the array. And they're also like resized down if you keep removing item from the array and then it gets to a certain threshold, you can also resize it down. The second is that for regular array, you can directly use the array square bracket index to access the item at that index. But for array list, you need to use array list dot get method. And then it's about like the For arrays, if you want to get the length or like the size of the array, you can just use array.length. And then for array list, you use .size method. And then lastly, for arrays, you must, during instantiation, you need to specify the type of the array when creating it. And then for array list, you initialize with array list script, this sort of bracket with object. And here's an example for the last point. For array, you use like int a equals new int. However, for array list, you need to pass in an object. So you need to use integer instead of just regular int. Is that clear? And lastly, here is the deck. So the difference between deck and a doubly linked list is that deck is more of like an interface, and doubly linked list could be one possible implementation of this interface. And then decks are basically double-ended queue, and it support 4 main functions: add first, add last, remove first, and remove last. And there is like a sentinel node for deck, as you can see here. Yeah. So here are some of my personal advice for like problem solving regarding those problems. Like for example, in an exam, you might be asked to add a method to like some sort of data structure. It could be like a deck or a doubly linked list or something. First, I will recommend drawing out the visualization and understand the structure and think about how this method will modify your current structure. For example, how your pointer is going to change, or like how things are going to be removed. For a deck, like if you have no idea where to start, I would always like think about using the Sentinel node, because that's the only thing we have direct access to. And for other things, you usually will have like sentinel.next or sentinel.prev or something like that. And then remember to use the existing methods like get index for array list. Any question for this part? No? Okay, then we will go into the practice problems.
Yeah, can I actually share my screen for this? Or it's like better for me to like click on the slides and point to stuff. Um, I don't think I have the access to share. Can you guys hear me, by the way? Uh, can you guys hear me? Wait, I think.
Okay. Did you connect it to the, does it have to be unplugged for you to do
Hello? Hello?
Well, I guess my audio hasn't been working. Oh wait, let me just plug in my computer.
Hello?
Oh yeah, we're trying to figure out how to get the audio working in the
Oh, okay, okay. Sounds good.
Yeah, need to plug in the same.
I can try to
So maybe use your computer.
like I can use
Okay, so I'm just gonna.
Yeah.
Okay, you have the link and everything.
Can you speak?
Hello?
We had to do something here with the touch. Wait, you might need to click on the should be sure rate digital.
So,
Oh no. It should, it should be. Oh,
what is there's arms.
Well, while we're sorting out the like technical difficulties, like the folks on Zoom can probably like just get a head start on this question. Since like the definition, the codes are given on the side being displayed here.
you're plugged in.
I'm
You're
not plugged in.
but
Still. So maybe that's on your computer side. Hello? Can you hear me?
Yeah.
Okay, I cannot hear you now. Hello?
Hello?
Can you speak again?
Hello?
Wait, can you guys in the WAS hear well enough off of just webcam? Like, it's kind of bad, but
I believe so.
okay.
okay.
Wait, can you start speaking?
Yeah. Yeah. Okay. Okay. All right. Can I request to share my screen?
Um, not the Zoom.
Wait, try it.
Also, it's not to.
Okay, it should work.
Okay.
Try sharing.
Yeah. Right. You guys can see, right?
Yes.
All right. So let's get into practice question one. Yeah, for this question, we're basically given like a class for integer list. This is like we can go through the class definition together. We have like an integer head. We have a int list tail. This is basically like the standard linked list structure that we just went over. Head stands for the value this current node is holding. Tail is just pointing to the next node. Yeah, and we have like a standard constructor over here. So for this question, we're gonna be dealing with some structure. We're gonna be manipulating the structure of this linked list and trying to like print some values along the way to see if we understand the structure correctly. Okay. I'll give you guys like 10 minutes to like briefly, oh wait, 10 seconds to like briefly look through the code, and I'm just gonna walk through it uh, each step. Yeah, so basically we're just like doing a lot of manipulation to some of the list, the nodes we constructed. Okay, here. So we first we have a node holding a value of 5, and we have a node B holding a value of 9, and they're both not pointing to anything. Both of the tails are no. And then next we have another node C that that has a value of 1 but is pointing to another node. Pointing to another node that's holding value of 7 and also pointing to list in list B. Okay. Now we set A's tail to be C's tail. So now A is pointing to C's tail. Okay, now we're taking that tail, A's tail over here, pointing to this node over here, and then we take its tail and make it point to B. Okay, now B's tail has never been set before. Now we set it to be um to C's tail. What is C's tail? So we take C and then we look at its tail. It's pointing to this node as well. Okay, lastly, we're creating a new node D. This node is supposed to hold a value of 9001. And then this tail should be pointing to B's tail's tail. Let's see over here. Value of 9001. Okay. So first we look at B. Uh, yeah, since B's tail is pointing to this node and this node is like pointing back to B. So actually in list D's tail is just pointing to B. When we print a value for this, uh, we'll get 9. Okay, for the next one, we have A's tail and head. We have A here, tail's pointing to here, and head would just be 7. Okay, now we're setting C's tail. See over here? C's tail's tail to be pointing to C's tail, which is pointing to itself. Yes. So this can actually happen in a linked list. Yeah, we're just like testing some weird behaviors. Um, okay, now we want to print eighth, tail, tail, and then tail, 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 and head. I believe this value should be 7. Yes. I went over this kind of fast. Do people have questions on this? Also, like Matthew, can you like look for people in the room if they have any questions?
Yeah, I don't think there's any questions.
Okay, we're good. Okay, moving on. Okay, for this question, we're basically like writing a short helper function that returns true only if an integer array contains an integer target x. So your solution may use at most 9 lines. I would like to give everyone like 3 minutes to work on this. Yeah, and we can come back to go through this together. Okay, hopefully that was enough time for everyone to at least give it a try on this question. Does anyone have any idea on how to approach this question? I know it's kind of like a little hard for me to like to hear a student. Oh, okay. Okay, hey guys. Okay, I think we can just like go through this. Okay, so basically we want a loop to go through all the elements for this array. It's kind of like a warm-up question how to deal with arrays. So we iterate through the array with a for loop structure. If our current element is equal to x, we just return true. Otherwise, after we're done iterating through all elements in the array, and we still haven't found the target x, we just return false. Okay, so this question is a little bit more involved. So basically, we want to construct a high dimension, like multi-dimension integer array. For example, if we have a 2D array, that will just be like int two brackets array. And then the first layer of that array will be holding elements that are basically another 1D array, which points to elements of integers. So we want to complete the constructor for this ND array, which takes in a dimension D and a width W, such that the ND array represents a n times W array. We may assume that D is greater and is at least 1 and W is at least 1 as well. So let's first look at some of the attributes for this class. We see the first attribute is like integer value. This is only being used when we are at the root of this array. So in a multi-dimension integer array, so the elements of that array should be another array for most of the times, unless we're hitting like the bottom level where we have all the leaves, and then those leaves are just like a regular integer element in in a 1D array. Hopefully that makes sense. So dimension is does anyone want to give a guess? Give it a try. Like what dimension is? What does it mean in this context? We are having like a multi-dimensional integer array. Does it represent our current dimension? Or does it like represent something else? So like when you're like navigating through this like array, we probably want to keep track of like how many dimensions are left to go through. If we're just like unraveling the array each time, if we're just like going into the array each time, by layer, yeah, we're just like gonna be decrementing dimension each time. So this will help us to understand like what is the dimension of the array for I guess for the child array over here. Does anyone want to like give a guess on what this variable means over here? So we have so if we have a leaf node, we use this variable integer value. If we're not leaf value, if we're not like looking at the leaf, we are probably this current array is probably holding elements of some lower level dimension arrays, right? And this variable is like to hold that array over here. So this dimension tells what is the dimension of this array that we are holding. Yeah, this array is just a child array. Okay, with those information, I think it's good that we at least give it a try, like figuring this question out. Maybe for like 30 seconds since we're short on time. Okay, so in the first line, we see like we're just like setting our dimension to be D. Um, and then when I see this line over here, so if something return, I I can see that this could be some sort of like base case over here. So what is like the most simplest case that we can see over here? So the simplest case I'm thinking is that if the dimension is 0, we just return, right? Since that is not even like a proper node anymore. And for this one, we're setting array to be equal to something. As we said before, array is like a child. It's like a child array when we're not at the most basic level. We're not looking at the leaves. So for this one, we're gonna create an array of width w as given from the problem description, and we're gonna pass this array to be the child of this ND array that we're creating. And then for each element of that array, it should be holding a less dimension array with the same width. That's what basically this for loop is doing here. So this question is a bit more involved in terms that it uses both recursion and also iteration to construct ND array. Okay, this question is like the second part. It's like a follow-up question to the last question. So we're just like wanting to, so given a list of integers called coordinates, we want to use these coordinates to correctly index into an element to read an integer value of that element. So for this if statement over here, we're just checking if the size of this coordinates matches our dimension. If not, we'll just throw an exception and stop the program. Okay. Since we're a little bit past our time already, let's just go through the solutions. So so this over here is kind of like our base case again. So if the coordinates is empty, we just return the value. That means we have indexed into the correct leaf, and then we just return the integer value at the base level. So if not, we want to take the to pop off the first element of our coordinate list, and then index into our current ND array, and then try to call recursion on the next layer of that ND array. Yeah, so here we're just popping off the first element, and then yeah, and then calling recursion to keep popping off the next coordinate and correctly index into the next level of that ND array. Does that make sense? Yeah, for example, like if you have like a 2D array, let's say, if you have a 2D array, you want a value at 2 comma 1, then how this runs is like first it gets so so first it gets like the 2, and then for the next iteration it gets 1, and then we'll hit our base case and just return this value. Okay, I believe this is the end of our review session. Thank you everyone for coming. Good luck on your midterm.